OsteoSignal with Neal O'Neal, Episode 2. This is OsteoSignal with Neal O'Neal, a podcast dedicated to helping you understand the osteopathic model of health so you can live a better life. Today's episode discusses oncogenes, parts of our genetic code that can cause unwanted cell growth, and their relation to arthritis and cancer. And now, here's Neal.
So today, I would like to talk to everybody about arthritis and cancer and how those two conditions are flip sides of the same coin. And so in our pursuit to understand medical science and medical decision-making and maybe provide understanding and knowledge on all things medical, this is something that I think people need to understand so that they don't get the wrong idea and then maybe take the wrong course of action and how they want to be treated. So I'm going to go back with that statement. Arthritis and cancer are flip sides of the same coin. And you might say, that is the craziest thing I've ever heard. Right? Yeah. So the reason for that is that there are these two growth control genes called oncogenes. Now, everybody knows what an oncologist is for, what an oncologist is for, who they are, what they do. They treat cancer. And so that is for this growth control gene that says, it's the instructions written in the DNA of a cell that say, if you're pushed on, die. So that cells don't overgrow their area and then push up against other cells and cause them to die. So if too many cells start pushing against each other, there's some problem going on. There may be a defect in the cell or something's going on. It's just this safety mechanism within the DNA that says, if you're pushed on, die, the cell should die. Now, a cancer cell has broken that, whether that's because it got exposed to a virus broke that gene by inserting itself right in the middle of it, or there was a chemical that caused that breakage in the DNA, and in that process, or there was, say, a cosmic ray or an X-ray or something else of that sort. Okay, so that's oncogenes, and we all understand the oncologist treats cancer and cell growth, right? So abnormal cell growth. Now the other oncogene is one that's less well known, and that oncogene says if you're pulled on, grow. Okay, so who would be the doctor for growth, this growth control gene? What would we call that person? Well, we often call him an orthopedic surgeon. And the reason for that is because sometimes this growth, now the growth that's normal is what we call like your elbow. The terms you'll hear are tuberosity, trochanter, like trochanteric bursitis. Well, there's a trochanter, it's a bump, and that bump grew because the muscle inserted there and pulled on it, and the more that you used it, or some people have knobbier knees than other people, or bigger patella. There you go. Soccer players, right? Anybody who ran, especially as a kid, when you're going through your growth stages, your developmental stages, then you have larger bone structure, and that bone structure has grown to meet the needs and the pull that was upon it. Some people don't have. Captain of the chess team didn't have big knees.
Yep.
So that's where we see this as a normal thing. Like, yes, you need this growth control gene to cause things to grow when they're pulled on, mostly by muscles, obviously the tendon bone insertion. However, what about when it's abnormal or something we don't want? Like, say, I went to the doctor and they said I have that horrible disease, arthritis. It's like, well, is arthritis a disease, or is it a natural process of bone growth that happens in an abnormal way? For example, you see a lot of arthritis or bone spurs right close to joints. Mm-hmm. And that's actually because most of a bone spur is there because of chronic pull on the bone and a structure that could do that. Now you would think, well, gee, a tendon could do that. And yes, especially when you have lots of human growth hormone flowing through your body or going through growth spurts, you're going to get a lot of bone growth in response because it's going to be very malleable and responsive to that pull. But as you age, it becomes a little less responsive. So you need something that pulls chronically. So your muscles tend not to be it. So even if you have tight muscles, people go, I have tight hamstrings. And yes, over time, you might get a knobby knee. The side of your knee will become knobby where the hamstrings insert. But for the most part, you don't really get a lot of large protuberance bone growth after that.
Sure. What
you do get are these bone spurs. And the bone spurs are where the capsule. So joints have capsules because joints have fluid inside of them. And so there's this fibrous capsule around the joint to hold the fluid in, the synovial fluid. Mm-hmm. And so
Is that fluid enable the joint to move like smoothly?
Exactly. That's the fluid. So all joints actually are not supposed to be cartilage contact. They're supposed to be on a fluid contact. So the fluid, you actually ride on a thin film of fluid, this synovial fluid. So great question. And that's why your cartilage doesn't wear out and you don't go bone on bone. Or when you do, it's because that synovial fluid has stopped being produced appropriately, or it's the wrong kind. But that's another story. Uh, this one, we're talking about that capsule that holds that fluid in. Now, capsules are one of those things that they usually are, first off, a bag that attaches around the joint. So on the two bones that make up a joint. And they often have thickenings over the top of them that we call ligaments. And the ligaments hold the joint together, like your ischiofemoral ligament, right? Or it attaches it, is a thickening on your capsules. So there you have it. But where are you most likely to get a bone spur? Well, where that ischiofemoral ligament attaches, but it's part of the capsule. So anywhere along the capsule. So somebody says, "Oh, I went to the doctor. I've had a painful hip for quite a while, and he said I have a bone spur, and that's why I have my pain." And so he offered me a cortisone shot or something like that, and to stop the inflammation. But that doesn't stop the process of the bone growth, because the bone growth is there due to pull on that capsule. So abnormal joint movement, a joint that has been either overworked or injured at some point in the past and has never gone back to its normal range of motion, such that that capsule gets even pull on it and has the ability to allow the bones to move through their full range of motion. So a lot of people say, "Well, I can't raise my arm over my head, or my hip can't rotate in. I can rotate out really well, but I can't rotate it all the way in." That's a huge problem, because that capsule is now pulling abnormally on the bone around the joint. And if that bone spur gets large enough, it will overgrow the joint and make it so that you can't move the joint from a bony perspective, and that's often surgical. But let's go back to this. It's not the arthritis itself is not a disease process. It's a natural growth process. Now, we're not talking about rheumatoid arthritis. That is a disease process. That's something else entirely.
Sure.
This is osteoarthritis, the normal, what they call, it's normal wear and tear arthritis. Just because we see it all the time doesn't mean it's actually normal. There's an abnormal state going on, but it's dysfunctional.
Yeah.
It's not necessarily pathological until this bone spur grows too large, and now it's a problem.
Mm-hmm.
Okay, so people need to understand that about what they're looking at. Like, yes, you have a bone spur, but remember that bone spur, first off, is in the thick of in the middle of very thick fibrous material. So that, and you get this all the time from people who say, "Oh, I have plantar fasciitis," and they took an X-ray, and there was this really sharp bone spur in there, and that feels exactly that's what's jabbing me down there. Not a chance, because that bone spur is only there because it's been pulled on by whichever structure is inserts in that portion of the bone. Not always the plantar fascia. There's plenty of muscles in your feet, intrinsic muscles and otherwise, that can cause that. There are plenty of capsules in your feet that can cause that, right? There are so many joints in your foot that, which capsule are we talking about? And for it to be your plantar fascia, you may have a bone spur there, but that's probably not the one causing your problem. That's more of that bone spur tends to actually be an indicator of a dysfunction, not the source of the dysfunction.
Yeah.
Right. So I'm not saying you don't have to go cut those out, but more than likely, that's not the cause. There's another cause. And again, it goes back to this capsule. So if you have a manual therapist that knows how to make your capsules work, that would be far more beneficial to you than the cortisone shot or PRP or any of these things, because a normally functioning joint stays healthy.
Yep.
Now, let's say that you had to get a hip replacement, nuclear option, the hip wore out. You still need somebody to go back and make sure that that hip works appropriately. Otherwise, the circumstances that were there that caused you to wear out your hip in the first place have not been changed. Just because the orthopedic surgeon restarted the clock doesn't mean the clock's not ticking. And this time it's ticking a whole lot faster because you've done plenty of other compensation and adaptation in your whole body to that injury. So you're just going to wear it out all the faster. So you still need somebody to restore the function of the area. It's the function that's the important part. The arthritis is not a disease. It's a process, and it's a process of dysfunction.
Mm-hmm.
So could you elaborate a little bit more about what is happening to the capsule that causes arthritis? Is it an aberrant motion, or is it some kind of, like, maybe you're comparing it to cancer, right? Are there some cells that the gene is not functioning properly, and so it's when it gets that instruction to, like, if it gets the pull instruction, it should die. That's not happening
Well, no, the pull
That would be
instruction
a-
is to grow.
Oh yeah, to grow. Sorry.
Yeah. So, I mean, and that's a great question because it's really like, okay, wait, it can be a little confusing here. The growth of the bone is normal for the circumstances. The abnormal part, you're saying, okay, what's the abnormal part here? Is
Yes.
that capsule has lost its ability to move because something happened to the joint. Either you used it excessively, like sitting. How many of us sit in the same position and we sit with our hips at 90 degrees and that capsule is stretched in a certain way and tight in a certain way. And then
Mhm.
we use the muscles that run across the top of it repetitively, like our iliopsoas and our glutes, right? And we use those muscles in a specific way time and time and time again. And pretty soon they've frozen down in such a way that they don't have the joint doesn't have its full range of motion. The muscles don't have their full range of motion. And that sets up this dysfunction of the capsule, which now has a constant pull that pulls on that.
And it's signaling those cells to grow because it's pulling
And that's
all the
the signal.
time.
And you're not riding on that synovial fluid anymore.
You stop
So-
riding on the synovial fluid. So you start
Mhm.
wearing up. Now you start going into first wearing the cartilage, then wearing getting bone on bone. You damage it. You cause it to be hot because you've irritated it. And so now the synovium gets thick and sticky as opposed to being serous, right? That's sympathetic tone in the hip. So yeah, it's a natural process, but it's a dysfunctional state.
Sure. What's the gene called that you mentioned with
It's
the?
an oncogene.
They're both
Both
oncogenes.
oncogenes. Growth control genes are called oncogenes.
Okay.
And that's why you've got to have someone that's trained, hopefully osteopathically, because I mean that's where we're coming from, right? But that can take the health history of that person and say, is yours because you tore your Achilles tendon, or is yours because you locked down your talus, or because you twisted your knee, or you have an injury to the ACL, or whether you have a hip flexor problem, or your diaphragm is stuck to the top of the psoas, or what it is, and they've got to be able to go back and find that because all of those things can cause a capsule somewhere, and that's where you can get bone spurs in different spots. Like you can have it on one side on one hip and different place on the other one, and that it's important to be able to find those hammers and get rid of them. So
Right. There's the deforming force, and then there's where that deforming force couldn't be either
Mhm.
dissipated or transmitted somewhere else.
right,
And those sites are often distant from each other. And that's really the osteopathic principle or osteopathic concept is don't draw a 6-inch box around a problem and expect to find the source of the problem there. That problem is often distant and is having an action at distance or a torque or a lever arm, which makes a small amount of force actually a much greater amount of force over distance.
hmm and I have to explain that with my patients too. Is they're like, well, am I gonna have surgery? I'm like, I don't even know yet. I mean, for a while, when someone comes in with a certain problem, you're like, well, either way, we have to take the hammer away, right? Whether we're gonna save the hip or we're gonna have to get the hip replacement. For a while, the treatment's exactly the same because you got to get the function to be restored and then fluids moving and all that kind of stuff again. So and then you get to a point, and then you're like, okay, this is where we're stuck. We either get a hip replacement or it fixes it. So
Exactly. You still need that treatment of restoring proper motion. Otherwise, you'll just wear out the replacement.
Yep.
And nobody wants that.
let's do this again.
Right.
Right.
That's fantastic. So what's the takeaway for our listeners
The takeaway
regarding this?
is to understand, like, why do you have arthritis? What is this osteoarthritis? How do you actually want to treat it? Do you want to treat within the 6-inch box? Is it that desperate? People are often just trying to get out of pain.
hmm
And they'll do just about anything to get out of that pain. And they go to a professional, a medical professional, who tells them, gee, we took a picture of the 6-inch box where you're having your pain, and we found some damage in there, and you have this disease. It's arthritis. Right? But no, it's not a disease. It's a process. And that process, it's like a sandy, a sandbar in a river. Why is the sand there? Because the river twists and turns and tumbles the sand along, and that just happens to be the place that it throws the sand.
Hmm.
But that upstream, there were rapids.
Yep.
And those rapids, wherever where those actual forces are coming from, that's where the problem is. So there's a bunch of smoke down in the hip, but the fire is somewhere else. Go put out the fire. Don't wave the smoke around and go, gee, yeah, we did something about it. Don't do a clamshell and just wave the fire around for the hip.
Or just go get stem cells or PRP, or because
What's PRP? Sorry.
platelet-rich plasma.
Plasma. Okay.
Platelet-rich plasma is a way. So the platelets have been deemed to be healing. The research that it's based on didn't actually point to this, but it doesn't matter. What they're doing is they're taking platelets out of your own blood, and then they'll go and inject it into a site in your body that needs to heal. And the beauty of platelets is they actually form, like if you get a cut and you start bleeding, these platelets will form a web, and then they get real sticky, and then everything sticks to them, and then they stop the bleeding and create a scab.
Yeah.
So they're great from that standpoint. So if you have something torn, like a partial tear or torn small enough, it's actually perfect because you can go in and squirt this in there, have a doctor squirt this in there, and it'll create a net that now will create a substrate to actually build back on. So if you've partially torn something, this is a way to, it's called regenerative medicine, right? You're trying to regenerate the joint or regenerate the problem. So it is a viable treatment. Again, why did that happen? Now, sometimes it's trauma. Don't go fall on inline skates again without pride. Or it's from a chronic process. Or maybe it was an injury a long time ago, but that now has resulted after all this time in this injury. And so you might use PRP for that sort of thing.
Sure.
Okay.
That doesn't mean you don't still need that capsule to move properly. And why can't the capsule move properly? Well, sometimes it's within the capsule, or sometimes it's an action at distance.
Distance, like you said, yeah.
Exactly. And you need somebody that can ferret that out, that doesn't just think inside of 6-inch boxes like most of medicine does, because insurance companies have told us, tell us what's in the 6-inch box that you're working on. Give us the diagnosis
We
code.
have a code for that.
We have a code for that.
Yeah.
And then we'll pay you for that code. And by the way, don't go anywhere else. Only look in that box.
Sure.
Yeah.
Yeah.
Which is guaranteed to fail.
Gotcha. Awesome. Well, thank you so much.
Perfect.
All right. Thanks. Thanks for listening to OsteoSignal with Neal O'Neal. For more information, visit pursuitpt.com or pursuitperformancetraining.com. Our music provided by Skytoes.